Welcome. This is PreCalculus V, Unit 1, Lesson 1. Unit 1 is an introduction to trigonometry. Lesson 1 is right triangle trigonometry. So this lesson really serves as a review of some of the things you probably learned in your geometry class. No accounting for whether or not you remember what you learned in your geometry class or not, but that's why we have this lesson here. So right triangle trigonometry. So first we need to define a right triangle, and this is all about right triangles only. Right triangle trigonometry. A right triangle is a triangle that has one right angle in it. One right angle. And I'm going to sketch a right triangle up here. Okay. And here we go. So we've got a diagonal side, which is the longest side of a right triangle, that is called the hypotenuse. We've got the vertical side here, which is one of the legs of the right triangle. And we've got the horizontal side, which is the other leg of the triangle. So these are both called legs. Okay. You already know the Pythagorean theorem that says the sum of the square of the legs is the square of the hypotenuse. Say that 6 times fast to impress some people. Okay. But the first thing we need to know is the anatomy of a right triangle. Okay, and we've got to identify these sides. Now, in this case, we have a reference angle. Reference angle. So with a reference angle, we name all the sides. Okay, the long diagonal is always called the hypotenuse, regardless of what side is the reference angle. But when we go opposite the reference angle, that is called the opposite side. Opposite side. And the side next to the reference angle, the leg next to the reference angle, is the adjacent. So opposite and adjacent are always legs. The hypotenuse is always the long diagonal across from the 90-degree angle. It is always the longest side of the right triangle. Okay? With that in mind, you may recall this simple mnemonic, Socatoa. Socatoa. Right? And I remember it this way. When I was in, before I started teaching here in the States, I spent a year teaching in the Marshall Islands. And we used to walk around on the coral reef with our zoris, our flip-flops, our sandals, so to speak. And coral is very sharp, and so one day I cut my toe on a piece of coral, and my toe became infected very badly. And so the doctor said I had to take a solution of hot water and bleach, quarter cup of bleach for a gallon of water, and soak my foot. So I had to soak a toe in bleach to prevent the spread of infection. Soak a toe. It's a way to remember the trig function. So stands for sine of x is opposite over hypotenuse, SOH. Ca stands for cosine of x equals adjacent over hypotenuse, CAH. Toa stands for tangent of x equals opposite over adjacent, right? So that's a way to remember the trig functions, and it's very important for solving. And we'll do a couple of examples. We won't exhaust all the possibilities because this is really only an intro video. You'll get more instruction in the lesson itself. So let's keep this on the screen, and let's bring up a new layer here, and let's provide some information. Let's say I've got a 32-degree angle, okay, and I tell you the hypotenuse is 15 inches, okay. And I ask you to find the lengths of the legs. Okay. All right. So here's what I'm going to do. If I shoot for this leg here, the x, I note that x is the opposite side, when 15 is the hypotenuse. So which trig function has opposite and hypotenuse, O and H? Well, the answer is so. So I know I need the sine function. So I write the equation sine of 32 degrees equals opposite x over hypotenuse 15. Okay? and then I solve the equation. And one word of caution here: don't evaluate sine 32 and give a decimal approximation at this time. I recommend you save the calculator for the last step. Manipulate the equation. So the opposite of divide 15 is times 15. So this is x equals 15 sine 32. You'll get more accurate answers if you wait to use the calculator on the last step. And then, of course, my favorite calculator is Desmos, so let's go grab desmos.com. Oh, Desmos, not Desleast, but Desmos. Desmos does the most. Graphing calculator. Okay, and I tell you, if I had one of these when I was in high school, I had a scientific calculator. It cost 20 bucks. And it would do sine, cosine, and tangent, but it was did way less than this does. So 15 sine 32. Okay. Now notice, by the way, that if I enter it right now, the answer may or may not make sense, and that's because I didn't do something here. The default angle measurement in Desmos and many calculators is radians. Radians, there are 2 pi radians in a circle, and that equals 360 degrees. But we need to measure our angles in degrees. So click the wrench tool in Desmos and click degrees. Make sure to do that, otherwise you're going to get some bogus answers. Okay, so to the nearest tenths, 15 sine 32 is about 7.9. So about, I'm going to say approximately 7.9 with a wavy equal sign. 7.9, and put units on it. Take 2 tick marks are inches, 1 tick mark is foot or feet. Good carpenter notation there. Okay. All right, and let's do another one. Let's do another one. This time, one that requires us to find. Well, actually, one that requires us to have the x on the bottom of a fraction. So adding a new layer and hiding that one. Let's say in this case, I happen to know the opposite side is 15 inches. And I need to know, or let's make it the adjacent side. The adjacent side is 15 inches, and I need to know the hypotenuse. So I note first that 15 is the adjacent side, A, and x is on the hypotenuse, h. So I need to know which trig function has a and h, and I note that that's cosine, ka, Socatoa. So I'm going to use the cosine function. Cosine of 30, and I forgot to put the degrees. Keep it the same, 32 degrees. Cosine of 32 degrees equals 15 over x. Okay. Now, I'm going to do something in 2 steps, but I want to show you how it can be shortened, actually. I'm going to multiply both sides by x cos 32. And then I'm going to divide by cosine 32. X equals 15 divide cos 32. Okay? And if you do this a few times, you'll notice every time the x is in the denominator, we just end up switching these two. The cos 32 and the x trade places. Okay? And so feel free to do that in one step if you like. Okay? When x is in the denominator, switch places. But in essence, you're doing these 2 steps. You're multiplying by x, you're dividing by cos 32. And then reach for a calculator. Go, oh, Desmos, like on Disney Clubhouse where they have, oh, Toodles. All right, 15 divide cos 32. Yes, I have small children. 17.7. Always make sure that your answer makes sense in the context of the problem. Does it make sense that it would be 17.7? And the answer is yes, it should be a bit bigger than 15. 17.7 what? 17.7 inches. Okay? All right, well, I want to show you one more, and this is one where we have to find an angle. Okay? So let's get a new layer here. All right, and this time I happen to know the opposite side is 4 inches, and the adjacent side is 6 inches. And the question I'm asking is, what is the angle? What is the angle? Well, first I note that 4 inches is on the opposite side of the angle, and 6 inches is on the adjacent side of the angle. So which trig function has opposite and adjacent? Oh, that's TOA, right? So I write the equation tan of x equals opposite over adjacent. I can reduce that if I want, right? But I know I'm going to reach for a calculator, so I don't have to. And here's the question: how do you find x when x is in the argument of the tangent function? And the answer is use the inverse tangent function. So x equals inverse tan, and the notation, the standard notation, is tan with a little -1. It looks like an exponent. It's actually not an exponent. This is not 1 over tan, which would be x to the -1. But this is inverse tan. This is the notation for inverse tan. Now, there are some other programs that use different notation. Desmos recognizes this if you use the keyboard pull-up. Otherwise, it recognizes arctan. And if you use Excel, atan, right? So, but all three mean the same thing. So we're going to find the arctan, or the inverse tan, of 4/6. So I'm going to show you both ways here. I can type ARCTAN, and in Desmos, when it's italics, it means it doesn't recognize it, but when it recognizes it as a function, it brings it up non-italics. And then 4/6, okay, and 33.7 degrees. 33.7 degrees. 33.7 degrees. Now, just to show you the alternate way here in Desmos, you can use the keyboard option here, show keyboard, and go to functions and trig functions. There's trig functions, sine, cosine, tangent, cosecant, secant, cotangent, but there's inverse trig functions as well. So you can bring it up like this: inverse tan 4/6, and it's the same thing. Okay. But I find typing arctan, if you remember to do that, is faster than reaching for your mouse. All right. So hopefully that helps. Now there's one more concept built into this, and I know this video is going a little long, but there's one more concept built into this, and I want to compare the angles here. So let's the two acute angles. Okay. The angles of a triangle add up to 180. So I'm going to call this angle x and this angle y. Okay? The angles here add up to 180. So we can say that x plus y plus 90, because this angle is 90, equals 180. And if I subtract 90, I can say that x plus y equals 90. So the two acute angles add to 90. And that's something worth knowing. But here's what I really want to point out: that any of the acute angles is equal to to 90 minus the other acute angle. Okay, so that means y is 90 minus x. Okay, so let's look at this here. I'm going to say sine of x equals, and I'm going to label these sides A, B, and C. Sine of x equals opposite, so opposite over hypotenuse, B over A. Okay? Whereas cosine of y equals, and this is really tricky to look at here because it changes the names. It makes this the reference angle, right? The hypotenuse remains the hypotenuse, but this is no longer the opposite. This is the adjacent, because it's touching the angle. This is no longer the adjacent. This is now the opposite. Okay? And so that would say that cosine y, cosine is adjacent over hypotenuse, is adjacent B over A. You'll notice then that sine x equals cosine y. Okay? And let me expand that out a little bit. Sine x equals cosine y. And let's replace y with 90 minus x. Sine x equals cosine 90 minus x. Okay, and this is one of your identities that you need to know. And it's true also for cosine. Cosine x equals sine 90 minus x. Okay, one trig function is the complements, the opposite or corresponding trig functions, 90 minus that. So it's the same either way. All right, so that's kind of important to recognize. Another way to think of it is when we get into graphing, sine and cosine are both offset from each other by a rotation of 90 degrees. When we get into the unit circle and graphing. All right, so hopefully that helps. Let me know if you have any questions.